In this video, we'll talk about some of the issues that we might encounter when writing out the simple linear regression model. Now, our goal is to get this ceteris paribus effect of x on y. Okay, and notice that in our in our simple linear regression model, we have lumped all other factors into u. Okay, and these happen to be unobserved. So you might wonder, well, how are we going to get to that ceteris paribus effect if all of these things are unobserved? Now, remember that what we've written out here is a simple linear regression model, but this is a population model. We haven't gone to the data and we haven't really estimated it. Okay, but when it comes to estimating this relationship between x and y, whether we want to capture the slope or we're trying to capture the intercept using a random sample of data, we absolutely must restrict how u and x are related. So much of econometrics is about the relationship between u and x, okay, these two things right here. So the first thing we want to do before we move to estimation is we want to make a simplifying assumption about u. So in other words, we're going to say that the average or the mean or the expected value, the average, mean, or expected value of u is equal to 0, right? So if you use the expectations operator, you can write this condition as this, okay? So the expectations operator is basically the averaging operator, right? So it's telling you, if you think about your example, our example with the fertilizer and soybean yield, we're basically saying that the average amount of land quality, which was going into u, right? We didn't control for the land quality in our regression. So if land quality was in u, then we're saying, let's normalize the average value of land quality to be 0. Or in our wage and education example, if we did not control for innate ability and how that affects wages, then we can say we're basically saying let's normalize, or let's assume that the average of that innate ability in our sample is equal to 0. And this is going to be pretty harmless, and I will show you how. So remember that this is what the simple linear regression model looks like. And notice that we have this intercept here, beta naught, okay? Now, here we are assuming that the expected value of u is equal to 0. The land quality or the expected value of the experience, a workforce experience or ability is equal to 0. Anything that is in u the expected value of that is equal to 0. Now let's assume for a moment that the expected value is not 0 but some constant. So here let's assume that the expected value of u is not equal to 0, but actually this equals some constant alpha naught. Okay, then we can rewrite this population simple linear regression model in this form. Okay, so here what I've done is just added alpha naught and subtracted alpha naught, right? If I do this, if I add alpha naught and I subtract alpha naught, nothing changes in this equation. So I'm going to add alpha naught here to the intercept, and I'm going to subtract alpha naught from u. Okay, now notice if this is written in this form, then u minus alpha naught becomes the new error. Okay, so let's write down here that the new error equals u minus alpha naught. And if we try to take the expected value of this new error term, then this is just equal to the expected value of u minus the expected value of alpha naught. The expected value of u, we said equals alpha naught, right? And the expected value of the constant is the constant itself, right, which is alpha naught, which is equal to 0. So basically what we got here was the expected value of the new error is equal to 0, right? So we can run with this assumption that the expected value of our error is 0. But what has happened here is that we've adjusted the intercept, right? So what would happen is that if the expected value of u is not 0, then the intercept will get adjusted. And the most important thing to notice here is that the effect of x on y, which is captured by beta 1, has not changed, even though we made all these adjustments, okay, to the intercept. So the important takeaway is that the slope beta 1 has not changed.